Okay, so how do we know if entropy is increasing or decreasing? What you're going to be looking at, you're going to look at states and at the number of molecules. Yes? So if you remember, what is our lowest entropy state? Solid. Yeah? What's our highest? That's gas. And we have liquid and aqueous. Which one is less random than the other? Liquid. Okay, so we have liquid, and then we have aqueous, and then we have gas, and that's because this is a mixture and this is pure. So pure is less random than a mixture. Okay, so that's low to high. So if we were to, let me just grab one of those. Grab a head in here. Found to be some good examples in here. So what if we have CaC2 solid plus 2 H2O liquid in equilibrium with C2H2 gas plus CaOH2 aqueous? Which side has lower entropy and which side has higher entropy? Products have higher entropy, and that means that as we go from left to right, entropy is increasing. So that's what you do in terms of telling whether it's increasing or decreasing. And we could say here that the maximum entropy, therefore, favors the products. Because remember, nature likes everything to be as random as possible. Did that answer your question? There are, if you're wanting more examples, there are some on page 48 in Hebden that you can take a look at. Yes? Okay, so let's say we had, that's a good one, C2H6 gas, and we're going to say, we don't know what that arrow is supposed to be, C2H2 gas and 2H2 gas, and delta H is 311 kilojoules. We'll throw that in there just for fun as well, okay? So more particles is more random than fewer particles. So here we have one gas molecule. Here we have 1 plus 2 gives us 3 gas molecules. So in this case, entropy is increasing. Did that make sense? There could be, and in that case, if you had 2HI, gas in equilibrium with H2 plus I2. Okay, because these are all the same type of molecule, this would be less random because it's pure. Whereas these would be more random because it's different things. It's a mixture, yeah. But while we're up here, I figure we might as well look at this one and say, what's happening to our enthalpy? Our entropy is increasing. What's happening to our enthalpy? So tell your partner, what side does the heat term go on? This is a positive value, so the heat term goes in the left. 311 kilojoules, yes. Okay. Now, if that's the case, is our enthalpy increasing or decreasing? And if you're unsure, draw yourself a little graph. Is the graph going to go up or is the graph going to go down? Well, if this is a positive value, we have to be starting low and we have to be finishing 311 kilojoules higher, right? We have to go up 311 kilojoules. And so enthalpy is increasing. Now, which side does entropy favor? And remember, entropy is symbolized by the letter S. Entropy. Does nature want entropy to be high or low? So entropy favors the high entropy side, which is which side? Products, because we got 3 gas molecules. How about enthalpy? Does enthalpy favor the reactants or the products? Yeah, it favors the reactants because low enthalpy side is favored. Yes? So if that's the case, if enthalpy favors the reactants and entropy favors the products, is this a spontaneous process? Spontaneous processes either go to completion. Is that what's happening here? No, because we've got one thing pushing that away and one thing pushing that away. So a spontaneous process is one that either goes to completion or that forms an equilibrium. Does this one form an equilibrium? Yes, it does. And therefore, this is a spontaneous process. The only time you'll have a non-spontaneous process is if your low enthalpy and your high entropy are on the reactant side. And normally we don't use low and high. What do we use instead? Instead of low, we use minimum. And instead of high, we use maximum. Okie dokie. Anything else we'd like to go over? Yes. That would be a reaction that goes to completion, because you have both, if you have both arrows pointing that way, right? So you would have low H and, or I guess I should say minimum H and maximum S in the products. That goes to completion. So that would be a one-way irreversible process. Yeah? Yeah, so if you've got an exothermic reaction that produces a lot of gas molecules, yeah, that's going to be a go to completion. Yes? If they both go left, that is a non-spontaneous process, and that is when the reaction will not occur. Yes? Yes. The KEQ will be in the neighborhood of 1, but in the neighborhood could be like 10 to the negative 4 or 10 to the positive 4. Do you know what I mean? Like, predicting your KEQ value based on enthalpy and entropy is a bit of a fool's game, other than to say, if they both predict the products, we say it's going to be very large. If they both favor the reactants, we say it's going to be very small. And then we say about 1 to mean anything between, like, you know, exponents of 10 to the minus 41 to 10 to the positive 41. Okay, so yeah, don't get too excited about the KEQ value from those. You would actually need to do a lot more math. There is math that you can do, but we're not learning that this year. So, algo más?